Hello everyone, welcome to a new tutorial of RCC in which we will study singly reinforced beams using LSM method. And here's a new type of problem in which cross-sectional area of the RCC beam is not given, but it is mentioned that it resists a bending moment of 68 kilonewton meter. Also, it is given that the dimension of one of the dimension of the beam, that is width, is d by 2 times, that is width is equal to d by 2. And also it is mentioned that the grade of concrete is to be used M20 and steel is 250. Also it is mentioned that effective cover is 50 mm. So let's just start the numerical. The given values are FCK, Fy, and all the dimensions, that B and B is equal to d by 2 and d is unknown. So what we have is moment value. This moment value will convert it into factored moment value, that is converted by using mu is equals to 1.5 into 68. So that comes out to be 102 kilonewton meter. Kilonewton and meter is converted into Newton and mm. So this comes out to be 102 into 10 raised to power 6. Also, based on the grade of steel, we can calculate mu limiting for Fe250, which is according to a table which provides value of mu limiting for Fe250, which says mu limiting is equal to 0.148 FCK into BD square. So here FCK value is 20, B is d by 2, and d will remain as such. So this value will come out to be 1.48 d cube Newton mm. So also we know that MOR is nothing but maximum bending moment that a section can resist. So equating both the values mu as well as mu limiting value, so which gives provides us the value of d cube, and from that we can calculate dimension of the one of the dimension of the section, that is effective depth, which comes out to be 410 mm. Therefore we can also calculate the overall depth. Overall depth can be calculated by using the effective cover value, and we'll add that effective cover value with the effective depth. So 410 plus 50 comes out to be 460 mm. That is the overall depth value, this one. From here we can also find out other dimension of the cross-sectional area, that is b. B is equal to d by 2, as that was mentioned in the question. So d is 410 and b becomes 205 mm. So hence the size of the beam is 205 into 460 mm. Now also we can calculate the XU max value, which is 0.53 d. Here d is 410, and we'll directly put the value in this formula. 0.53 into 410 is equal to 217.3. Therefore, as we all know that the cross section, the beam section is balanced for now, so we can equate the forces on the compression side to the forces in the tension side. The compression forces is 0.36 FCK B into XU max is equals to, this is tension force, that is 0.87 Fy AST. From here we can calculate the area of steel in tension that is asked in the question. So area of steel can be calculated as we'll put all the values here in the denominator. So 0.36 into FCK value is 20, and the B value is 205 and XU max value is 270. and on the denominator side 0.87 into fy value is 250. So from here we can calculate the ast, and that comes out to be 1475 mm square. Now in order to calculate the number of bars in the ast, by using ast value, we'll suppose, or we'll calculate roughly the area of one bar of either 16 mm and either 20 mm. So firstly we'll calculate the area of 20 mm bar, which will be like this: pi by 4 into d square. D square is 20 we have considered, so which comes out to be 314.1 mm square. Now in order to calculate number of bars, we'll directly divide this ast value with a single bar area, which will provide us the number of bars required. So this comes out to be 4.69, which is approximately equal to 5 bars. So either we can calculate for the 16 also, but here it is sufficient that 5 bars are required in the tension zone of 20 mm dia. So therefore we'll provide 5 bars of 20 mm dia. Therefore the new area of the steel in the tension zone will multiply the area of 20 mm, area of 1 bar of 20 mm into 5. That comes out to be 1570.5 mm square, which is approximately nearby value to the one that we have calculated. This one, not that one, this one, upper one. Okay, so that's all for the question, and this was the thing that was asked in the question, that we have to calculate the area of steel, and also provide number of bars required in the section, and also we calculated the area, new area of steel in tension, which is 1570.5 mm. So that's all for the question today. Stay tuned for new videos, and please do like and subscribe the channel. Thank you.